4-6, graphs of tangent, cotangent, cosecant, and secant. Tangent is a little different than sine and cosine. When we did sine and cosine, we had a period of 2 pi over b. Because the length of sine and cosine, one cycle, is 2 pi wide. The tangent, however, is only pi wide, so its period is 2 pi, or is pi over b. So it's going to be a little different, it's going to be a little shorter. Tangent, as you know, in the past, is sine over cosine. So that means it's a fraction. If you remember right, when we do fractions, there's one number you're not allowed to have on the bottom, which is 0. So tangent doesn't exist when the bottom is 0, which means tangent does not exist when the cosine equals 0. So what you have to think about is when you do your key points for cosine, when do they equal 0? If we list them out, cosine's key points at 0 we're at 1, at pi over 2 we're at 0, at pi we're at -1, at 3 pi over 2 we're back to 0 again, and when you hit 2 pi you're up to 1. So where does cosine equal 0? Well, cosine equals 0 at pi over 2 and 3 pi over 2. So if you were graphing this, if you were to keep it going and do some more graphs, this was pi and this is 2 pi. Your graph doesn't exist at pi over 2 and at 3 pi over 2. To not exist means you can't cross that line. Now, we've done this before and we talked about graphs before. When they don't exist on the bottom, we call them vertical asymptotes, remember? So for tangent, you get vertical asymptotes at every half a pi, whether you're going half a pi to the positive or half a pi to the negative. You get vertical asymptotes. That means our graph cannot cross them. So you have to draw imaginary lines that you cannot cross. And we do that by doing dashed lines. So that means our graph cannot cross at every half a pi. And I can keep this pattern going because tangent, just like sine and cosine, goes on forever in both directions. At every plus and negative and positive half a pi, you got an asymptote happening. So when you go to graph, one thing that's nice about tangent is it's actually easier than the others to graph. Tangent is usually centered at the origin. So you're always going to have an x-intercept that is between the two asymptotes. Every two asymptotes, directly in between the two is where your center is located. So if we locate our centers, in between our two asymptotes, you have a center. In between the next two asymptotes, you have a center. In between the last ones, a center. And you can keep the pattern going as far as you want. That's where your graph is centered. Now, we're going to graph these using some key points. On an original tangent graph, you have key points at 0, 0. The next key point would be at pi over 4, 1. So, at 0, you go over to a quarter pi and go up to 1. And negative pi over 4, -1. So you go to quarter of a pi and down to 1. Those are your key points. Now, how do you relate them to the others in order to draw additional ones? Well, it's actually kind of easy. Easiest way to think about this is this way. If you know where your center is, okay, all you have to do to get your other key point is you go between your center and your asymptote. Right here's your center, here's your asymptote. You go over halfway in between the two and you go up to 1 and draw a point. You go halfway in between your center and your back asymptote, go halfway in between and go down to -1 and draw a point. And it's the same pattern every single time. We could do it on the back center. Halfway in between my center and my front asymptote, go halfway in between, go up to 1, draw a point. Halfway in between my center and my back asymptote, halfway in between, go down to -1, draw a point. And this pattern can go on as many times as I want it to, forever and ever on both sides, as far as I want. So in order to draw a tangent graph, you have to locate where the asymptotes are and locate your center, and your other 2 points follow suit. You have to go halfway in between and up to 1, or halfway in between down to 1 to get it. So let's take a look at this one, okay? This part we're not going to use because I got a better one. To find 2 consecutive asymptotes, you first have to find the period, and you have to cut it in half. If you do that, then you know where your asymptotes are. So let's take a look at this one we got right here. Period is pi over b. So the b in this case, oh, forgot the x, is the value that's with the x. And our b in this case is pi over 4. So our period becomes pi divided by pi over 4. We can't divide fractions, so we're going to multiply by reciprocal. So we get pi times the reciprocal, which would be 4 over pi. So the pi's would cancel out, and we have a nice, neat period of 4. Now, what's nice about tangent graph, tangents are always centered at the origin unless you're adding or subtracting anywhere. And in this one, we're not adding to the x, and we're not adding to the y, the vertical. So this one's a nice, neat center. So we already know our center of our graph is going to be at our origin. And since that's the center of our graph, and our entire period is 4, the entire graph has to be 4 wide. And if it has to be 4 wide, and you know your center's at the center, at the origin, that means half of it has to be on one side, the other half has to be on the other side. Total all the way across has to equal 4. So if we take our period and we cut it in half by dividing it by 2, that means we're going to have asymptotes at plus and minus 2. So if we do our graphs, that means we've got asymptotes located at 2 and negative 2. Those are the spots we cannot cross. So keeping that in mind, take a look. From the back asymptote to the front asymptote, how much spacing do you have? If you count your spacing, look and see what you got. 1, 2, 3, 4, which makes sense because you should have a period of 4 all the way across. Half on the front half of the axis, half on the back side of the y-axis. So when we go to graph, we already know our center. There she be. So there's no number in front. So we know we have a height of 1. So we go halfway in between our center and our front asymptote, halfway between, and go up to 1 and put a dot. Then we go halfway between our center and our back asymptote, halfway in between, go down to negative 1 and put a dot. And we have a nice, neat graph. Now we can change that graph out if we wanted to. Suppose I write it as 1/2 tangent pi over 4x. The only part that's changed is the height on it, which means instead of going up to 1 and negative 1, I'd only go up to 1/2 and negative 1/2. But everything else would stay the same because nothing else has changed. So my graph would look something like this instead. And downward towards my asymptotes. Oops. What if I changed it and I made it look like 3 tangent pi over 4x? Well, the pi over 4x means my period's still the same. I'm still going to hit at negative 2 and positive 2 for my asymptotes. But this time I have a height of 3. So that means instead of going halfway over and going up to 1, I would go halfway over and go up to 3. And halfway over and go down to 3. And my graph would look like this instead. What if I changed it out and I added a negative to that out front there? And if I put a negative in front of the 3, that means instead of going up on the positive side, I would go up on the negative side. So on the back half, I'd go up to 3. And on the front part, I go down to 3. And my graph would look like this instead. All right, really bad, but you go through the point. cotangent. Cotangent is cosine over sine. So it's just the reversal. On tangent, the graph didn't exist when cosine was 0 because for tangent, cosine was on the bottom. But for cotangent, sine is on the bottom, which means this graph doesn't exist when sine equals 0. So we have to figure out when sine is 0. So we need our key points for sine. And for sine, if you remember what our key points are, it crosses at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So on this one, you've got 3 places where your sine is at 0. Or if you look at it, you've got 0, pi, 2 pi. If you keep the pattern going, then it would be 3 pi, 4 pi, 5 pi. Or reverse it, negative pi, negative 2 pi. So sine asymptotes exist at all the pi's, plus or minus pi's. Okay? So if we did that, if this was a pi, this was 2 pi, negative 2 pi, our graph does not exist at those pi marks. So the graph doesn't exist at pi, doesn't exist at 2 pi, doesn't exist at 0, doesn't exist at negative pi, or negative 2 pi. And you could continue the pattern as far as you want. So for cotangent graph, it's the same deal though. You still got to have a center. Your centers occur in between each one of the asymptotes, halfway in between at the origin, or at the x-axis. So halfway in between would be here, halfway in between, halfway in between, and halfway in between. And the rules of how you get your other 2 points is exactly the same for a cotangent graph. Halfway in between your center and your outside asymptote, halfway in between, go up to 1, put a dot. Halfway in between your center and your back asymptote, go down to negative 1, put a dot. And you've got the cotangent. Do it again on the next one. Halfway in between, go up to 1. Halfway in between, go down to negative 1. Halfway in between, go up to 1. Halfway in between, go down to 1. And you can keep this pattern going as many times as you want. Cotangent graph looks exactly like tangent graph. The only difference is tangent graph is centered at the origin. Cotangent is a half a pi off from the original. So let's try one on our own. This is 2 cotangent of x over 4. So let's find our period first of all. The period is the same, pi over b. In this case, b is what's with the x. And if you remove the x, you still got a 1 there, so your b is 1/4. So you get pi divided by 1/4. We don't divide fractions, so we got pi times 4 over 1. So I have a period now of 4 pi. That's my period. Okay? Now, cotangent, if you look on the preceding page, if you follow what we just did on the preceding page, remember? Cotangent actually starts at 0 and goes forward, doesn't it? Or starts at 0 and goes backwards. It's not centered at the origin, is it? That's where your asymptote is. So you have to think of that in the same way here. So that means, oops, wrong side. That means I'm going to have a asymptote right on the axis, and my next one is going to be the length of my period, which is 4 pi. 1, 2, 3, 4 pi. So that's going to be my next asymptote. So I do it the same way. I figure out where the center is. So halfway in between the two, there's my center. And since I'm not shifting up and down any, I don't have to move it up and down. And since I have no plus or minus inside with the x, I don't have to shift it left or right. All I got to do is my height. My height is the number out in front, which is 2. So halfway in between my center and my lead asymptote, I go halfway and I go up to 2 and put a dot. I go halfway in between my center and my back asymptote, and I go down to 2 and put a dot. And I have my cotangent graph. And that pattern could be repeated over and over and over again as many times as you need.